Hi guys, it's Mrs. Harmison here with your 3B chemistry notes. In this lesson, we will learn to use the conservation of mass to balance chemical equations. This is an important skill that you will use throughout the rest of the year in chemistry. The law of conservation of mass, also called the law of conservation of matter, states that matter constantly changes form, but it cannot be created or destroyed. What this tells us is that the mass on the left side of the equation must equal the mass on the right side of the chemical equation. There must be the same number of atoms of each element on the right side and the left side of the chemical equation. Another way to think of this is that you must have the same number of moles of each element on the left hand and the right side of the equation. There are very few rules to balancing equations, but they are these. You can only change the coefficients. You are not allowed to change the subscripts of any of the chemicals in the equations. You must reduce. If you end up with coefficients that can be reduced, you have to reduce them. You can have no fractions or decimals in your final answer. So if you have those, I'll teach you later what we have to do. And then the final rule is you can never have a coefficient of 0. You can have a 1 for a coefficient, but 0 would mean that you have none of that substance. A coefficient is a full-size number that is written before the element or the compound. As you can see in this compound, there is a coefficient of 4. A subscript is a small number that is written after an element. In this compound, the subscripts are the 3 and the 2. To figure out how many of each element there are, you are going to multiply both by the coefficients and by the subscripts. For calcium, there is 4 atoms of calcium because there is a coefficient of 4. For the nitrogen, we have to multiply by the 2 because it is outside the parentheses that the nitrogen are in, and then we have to multiply by the 4 as well, so we get 8. For the oxygen, we have to take the 3, which is the subscript on the oxygen, and multiply it by the 2, which is outside of the parentheses that the oxygen is in, and then multiply that number 6 by the coefficient of 4. So we get 24 oxygen. Often you will want to keep polyatomic ions together. So if we were to keep the NO3 together, the nitrate, we would have to multiply the 2 outside the parentheses by 4 to get 8 nitrate ions. It is important to understand that these numbers tell us how many moles of each element we have. In order to balance an equation, we are first going to make a list of each of the elements that we see on both sides of the equation right underneath the arrow in the chemical equation. So my list includes Na sodium, O for oxygen, Ca for calcium, and P for phosphorus. Next, we're going to count how many of each element we have on the left side. We have 2 sodiums, 1 oxygen, 3 calcium, and 2 phosphorus. Now we will count how many of each element we have on the right side. We have 3 sodiums, 1 phosphorus, 1 calcium, and 1 oxygen. Please notice that the numbers on the left-hand side read 2, 1, 3, 2, and on the right they read 3, 1, 1, 1. We want to get to the point where those numbers are exactly the same. That's when our equation will be balanced. All we can do is add coefficients. Remember that we are not allowed to change the subscripts. When we look at our list, we see that sodium is not balanced. It has 2 on the left and 3 on the right. This is something you're going to want to look out for. When you have a 2 and a 3, The easiest way to get them to be balanced is to get each of them to 6. So we will multiply the sodium on the right-hand side by 2 to get it to 6. When we put the coefficient 2 before the Na3P, it does change the sodium to have 6 because you take the 2 times the 3, but it also changes the phosphorus to have 2. So you have to make both of those changes on the right-hand side. We have changed the sodium on the right-hand side to 6, but our sodium on the left still only has 2. So we put a coefficient of 3 before the sodium oxide, and you multiply the 3 times the 2 to get 6. That also changes the oxygen to have 3. In order to balance the oxygen, we put a 3 before the CaO, which changes both the calcium and the oxygen to 3. And as you can see, we are balanced. We have numbers 6332, 6332. If you were to write down an answer, however, what you would write is the coefficients. So we would write 3, 1, 2, 3. That would be the answer we would put on an assignment. An important thing to learn is that when you are balancing equations, you can leave polyatomic ions together. As long as you have the same polyatomic ion on the left side as you do on the right side, it's way, way easier to leave them together. In this case, we're going to leave the sulfate polyatomic ion together as well as the hydroxide polyatomic ion. So our list includes iron, sulfate, potassium, and hydroxide. Anytime you have the same polyatomic ion on both sides, you definitely want to leave it together. Now we're going to do the same thing as we did before. We'll make a list of what we have on the left side. We have 2 irons, 3 sulfates, 1 potassium, and 1 hydroxide. On the right, we have 2 potassium, 1 sulfate, 1 iron, and 3 hydroxides. Since we don't have any elements that have a 2 on one side and a 3 on the other, we can start anywhere. I can start by putting a 2 before the FeOH3, which changes the iron to 2 and the hydroxide to 6. I then need to change the hydroxide to 6, so I put a 6 before the potassium hydroxide. Adding that coefficient of 6 changes the potassium to 6 and the hydroxide to 6. On the left we have 2366 and on the right 2126. To balance the sulfate to 3, we put a 3 before the potassium sulfate, which makes the potassium be 6 and the sulfate be 3. And as you can see, our equation is now balanced. The answer we would write would be 1, 6, 3, 2, because those are our coefficients. Another tip that I want to teach you is that sometimes it is very helpful to break water into hydrogen and hydroxide. This is useful when there is a hydroxide on the other side, as there is in this chemical equation. So we're just going to cross out this water and write it as H-OH to show that it's 1 hydrogen and 1 hydroxide. Then we make our list in keeping the hydroxide together and also keeping the phosphate, which is on both sides, together. Why don't you pause the video now and try to balance this equation and then check my work to see if it's the same as yours.